us tonight, a major breakthrough in the treatment of patients who suffered a heart attack. Hundreds of thousands of people across the UK are living with debilitating heart failure. Often heart muscle dies off during a heart attack and can't be regenerated. Then the only answer is a transplant. But now researchers in Cambridge have proven that stem cells could be used to restore muscle. The British Heart Foundation says the research is at an early stage, but it's desperately needed and could lead to patients being able to literally mend their own hearts. Kate Bradbrook reports.
David Burnett is a retired nurse and grandfather of two. One of his hobbies, writing and illustrating books. In 2011, he went to the doctor with a suspected chest infection. The reality was far more serious. He needed a quadruple heart bypass.
It was a bit of a shock to the system. Your world suddenly stops, and everything that you've been getting on with, that you're taking for granted on a day-to-day basis, that's suddenly hanging in the balance. And you're thinking, will I get back to that, or won't I? Normal life just hangs by a thread, really, at that point.
David's one of the lucky ones. He's responded well to treatment. But for many patients with heart failure, there are limited options. Only around 200 heart transplants are done in the UK each year, which is why scientists here at Cambridge University are trying to find an alternative. They're using a unique combination of stem cells to replace lost heart muscle.
So an average heart attack wipes out around 1 billion cardiomyocytes. So that's a huge number of cells that patients lose during such an injury. And our attempt here really is to generate heart muscle cells at a very large number and try to bring the heart muscle back to the injury, to the infarct scar, and give it back its contractility.
So far, the process has only been trialled in rats using human stem cells, and the results are promising.
What we've got growing in this dish are the heart cells that we've generated from human stem cells. These heart cells are beating, and we put these cells together with the epicardial cells, and we inject these into damaged hearts. If you have a look down the microscope, you'll actually see these heart cells beating away.
This is the result of 5 years of research, an international collaboration between the universities of Cambridge and Washington, partly funded by the British Heart Foundation.
We have close to 1 million people living with heart failure, and we desperately need new treatments, revolutionary new treatments, to offer hope to the remaining patients who cannot receive transplantation.
Scientists believe this is a huge step forward, but there's still a lot of work to be done. If all goes to plan, clinical trials could start within 5 years.
Well, Kate is here and joins me now. Kate, this is a big breakthrough, isn't it? They've been experimenting with stem cells for years, but this is the first time they've had some real success.
Yes, scientists around the world have already been using stem cells, turning those into heart cells and trying to repair broken hearts, essentially. The difference here is that scientists have turned those stem cells into epicardial cells. That's the membrane around the heart. And they say the combination of the heart cells and the epicardial cells is really making a big difference.
But we're still a long way from people actually getting this treatment.
Yeah, it's a big step. We're not there yet. There are two massive hurdles that need to be overcome. The first is that this has only been actually tried in rats. It needs to be safe before it's tried in humans. The second is the scale. So rats' hearts are the size of my thumb. A human heart is the size of my fist. So a rat's heart needs 10 million cells. A human heart needs about 1 billion cells. And so that's a massive upscale. So we're talking around 4 to 5 years for clinical trials. If they're successful, it could be 12 to 15 years until it's available as a treatment.
Very exciting though, Kate. Thank you very much indeed. The funeral of a teenager